Hi boys and girls, welcome back to the channel. I'm Mr. Peck here. Today I'm going to help you out with questions on conservation of linear momentum. Let us jump into the questions. Two objects A and B with mass 2 kg and 3 kg respectively are moving in the same direction on a smooth horizontal surface. The velocities of A and B are 4 meters per second and 2 meters per second respectively. A and B collide head-on so that the velocity of B becomes 3.6 meters per second after the collision. Find the velocity of A after collision. Okay, so information given, we have the mass. Okay, we put this A and B. We have two objects here, A and B. A we put as 1, B is put as 2. So we have their masses, M1 and M2, moving in the same direction. So the velocity of A and B, this is the initial velocity, and they are moving in the same direction. So we assume that they both move to the right. We both move to the right. So both are positive value. Both move to the right. U1 and U2. They collide head-on. So this is considered a one-dimension collision. One dimension. Yeah, only one component. There's no XY component. When head-on means the only one dimension. Only one component. Now, so that the velocity of B becomes 3.6 after the collision. So this is the final velocity for B. So B we put as number 2. So this is V2, final velocity for number 2, for ball B. Okay? So find the velocity of A, that means after collision, means this is the final velocity for 1. We want to find V1. Alright, so I have illustrated the information in the diagram here. So these both balls, A and B, we have M1, M2, their masses, their initial velocity, both positive, moving to the right. And the final velocity for ball B, also positive, because it gives positive value, so it is to the right also. We want to find V1. So, what principle can we use? Yeah, it's the conservation of momentum. Yeah, for collision, conservation of momentum always applied. Okay, so what is the formula for conservation of momentum? Let us write it out. Conservation of momentum is M1U1 plus M2U2 equal to M1V1 plus M2V2. Okay. So we just substitute all the information we have. We have 2 kilogram 4 plus 3 kilogram 2, and then we have the this one. We don't have V1. We don't have V1. We want to find V1, and mass 2 is 3 kilogram and 3.6 for V2. Okay, so just left with V1. We find the answer, and we get positive 1.6 meter per second. So the positive value, what does it tell us? It tells us that the ball A is moving to the right also. Okay, so we must write the direction. Yeah, for vector velocity, always have magnitude and direction. You must give direction. If you don't give direction, you lose 1 mark. Okay, so we got positive value, means it's moving to the right after collision. Okay, now let's just move on to the question B. State with reason whether the collision is elastic or inelastic. Is it the collision elastic or inelastic? How to identify? Is it elastic or inelastic? Which one? First, you must know the similarity and also the differences between elastic and inelastic collision. Okay, So there's a quick note to compare between elastic and inelastic collision. Okay, so what's the this is elastic and inelastic. What's the similarity between them? Yeah, the same thing for elastic and inelastic collision is momentum always conserved. Momentum always conserved no matter it's elastic or inelastic collision, which is total momentum before equal to total momentum after collision, or m1u1 plus m2u2 equal to m1v1 plus m2v2. This formula can be applied for both elastic and inelastic. So we cannot use the conservation of momentum to differentiate between elastic and inelastic, because this formula can be applied for both. So the only thing we can use to differentiate between them, elastic and inelastic, is the kinetic energy. Okay? For kinetic energy, elastic collision, the kinetic energy is conserved. But for inelastic collision, the kinetic energy is not conserved. Okay? So the kinetic energy formula is half mv square. Okay? So the conservation of kinetic energy is half m1u1 square plus half m2u2 square equal to half m1v1 square plus half m2v2 square. This formula can only be applied in elastic collision. Cannot be applied in inelastic collision because the before and after not equal the kinetic energy. Okay? So how to do the question B? How to identify whether elastic or inelastic? We just check the kinetic energy. Okay, so we just check the kinetic energy before and after. So we just calculate the kinetic energy before and the total kinetic energy after. We compare. If kinetic energy before equal to kinetic energy after collision, then this is elastic collision. If the kinetic energy before is not equal to total kinetic energy after collision, not equal, then it is inelastic collision. Okay, based on the only difference between them, this one, kinetic energy. Okay, so let us substitute all the information we have. We did have all the masses and all the initial and final velocity, so we just substitute the information, shall we? Okay, let us substitute all the information we have. We have the okay, we just substitute half. Okay, half mass 1 is 2, u1 is 4, and mass 2 is 3, u2 is 2 square. So we calculate, we got 22 joule. Okay, that is initial kinetic energy. And the kinetic energy after collision, we also already have all the data. We just substitute mass 1, v1, okay, and then we have mass 2, 3, and we have v2, 3.6. And we got 22 joule. Oh, so it seems that this kinetic energy before and after is equal. Okay, initial. So we can conclude that total initial kinetic energy is equal to total kinetic energy after collision, which is 22 joule. So what does this tell you? It tells you that this is a elastic collision. Okay, because they have equal the kinetic energy before and after collision, and kinetic energy is conserved. So this is elastic collision. Okay. So that's all for the questions. Okay. So hope you enjoy the videos. Any questions? Any things you don't understand? Please leave a comment below. Okay. Hope you subscribe and bye. See you again.